Good morning, students. Today, new lesson, Unit 7, Thermodynamics. Thermodynamics means flow of heat. In Greek word, thermos. Thermos means heat. In dynamics means flow. That means thermodynamics means flow of heat. In our daily life, across many useful reactions. Many useful reactions. Example, burning of fuel. Burning of fuel to produce the heat energy. To produce the heat energy. That is first example. Second example, flow of electrons. Flow of electrons through circuit produced electrical energy. Produced electrical energy. Second example. Go to third example, metabolic reactions. Metabolic reactions to produce necessary energy for biological functions. Energy for biological functions. In 19th century, scientists tried to understand the underlying for steam engines. Steam engine that developed and how to use that only 19th century scientists discussed. Thermodynamically evaluated microscopic properties, heat and work only. Heat and work only. Interrelationship deals properties of system in equilibrium independently any theories properties in individual molecules which constitute a system only. In thermodynamics, based on three laws. Based on three laws. First and second law. First and second law. Conversions of different forms of energy. First and second law. Conversions of different forms of energy. The third law. Third law, calculation of entropy. Calculation of entropy. That means absolute zero kelvins. The study of first law, second law, third law, before you have to basic terms of two types. First one, system. Second one, surroundings. First you have to understand system. The system means imaginary boundary only. System means imaginary boundary only. That surrounded it happen. This is for universe. The outline is having universe. The gap is called surroundings. Gap is called surroundings. The inside the system is called boundary. Inside system is called boundary. Surrounding system are called universe. That the system is a part of universe under thermodynamic consideration, separate from the rest of the universe, that is real or imaginary boundaries only. Now example. First one, water in a beaker. Water in a beaker. That other example, balloon filled with air. Filled with air. Aqueous solution of glucose. Aqueous solution of glucose. They are system example. Aqueous solution of glucose, etc. System consists of two types, physical and chemical properties, divided by two types. First one is the homogeneous. Second one is the heterogeneous. That homogeneous means physical state of all constituents will be same. Example, mixture of gas. Mixture of gases. Second, system will be heterogeneous. Physical and all continuation is not same. That means different. Example, mixture of oil and water. Mixture of oil and water. Next, surroundings. Everything in the universe that not in the part of the system is called universe. Next, boundary. Anything with separate the system from surrounding called boundaries. Surrounding means everything universe that not in the part. Boundary means anything which separated system from the surroundings called boundaries. Next, types of system. There are three types of thermodynamic system will be. First one, open system. Second one, closed system. Third one, isolated system. First one, open system. Exchange of both matter and energy. Matter and energy. Both are is exchange. That system is called open system. Example, hot water contain open beaker. So matter and energy will be, both are is transferred to the surroundings. Matter means water vapor. Energy means heat. Both are is exchange. Next, second, closed system can exchange only energy, not matter. That system is called a closed system. Example, hot water contain closed beaker. Previously open beaker, now closed beaker. Another example, gas contain cylinder fit with pistons. Cylinder fitted with a piston. That system is containing closed system. Next, isolated. Exchange neither matter nor energy in surroundings is called isolated systems. Hot water contain thermoflask. Hot water containing thermoflask. Thermoflask inside means that matter not going, energy not going. That system is containing isolated system. Next, properties of system involved two types. First type, extensively property. Second type, intensely property. Extensively property means depends on mass or size. That property is called extensively property. Intensely property means independent of the mass or size. That property is called intensely property. It depends on the mass or size means extensively. Independent on the mass or size means intensely. Extensively properties in example, volume, number of moles, mass, internal energy, etc. Intensely property example, refractive index, surface tension, temperature, boiling point, freezing point, molar volume, etc. Typically list of extensively and intensely properties. Extensively properties, volume, mass of amount of substance, energy, enthalpy, entropy, free energy, Keen capacity. Intensely property, molar volume, density, molar mass, molality, mole fraction, molality, specific heat capacity. Next, thermodynamic process. The method of operation Change in system is called method of observation. Change in system is called thermodynamic process. Example, heating. Heating also change in system. Second one, cooling. Cooling also change in system. Third one, expansion, also change in system. Fourth one, compressions, also change in system. Fifth one, fusion. Fusion also change in system. Sixth one, vaporization, also change in system, etc. Some thermodynamic system will be given in the book. Types of system. First system, reversible process. Reversible process. First one, reversible system. That reversible system means initial state to final state. Final state to initial state without producing any change. Without producing any change in universe is called reversible system. That reversible system consists of important conditions. First, process should be infinitive, that initial to final, final to initial. Second condition, system and surrounding must be equilibrium. System and surrounding must be equilibrium. That means initial reaction forward to final state, final state backward to initial state. That is, two conditions will be followed. That is reversible process. Second, irreversible system. Initial state to final state cannot be restored. Cannot be restored. That system is called irreversible process. All the process occurring in nature, irreversible process. System and surrounding not in equilibrium. Equilibrium means forward and backward. Not in equilibrium means that only initial to final, not come back to final to initial. That system is called irreversible process. Next, adiabatic system. System and surroundings. System and surroundings, no exchange of heat energy. No exchange of heat. That means symbol is Q. Q means exchange of heat. Here, no exchange of heat energy from system and surroundings is called adiabatic process. That condition thermally insulating the system. That work done by the system, temperature will be decreased. Temperature will be decreased. Work done by the system. Next, isothermal process. Initial state to final state. In this process, temperature only constant. Temperature only constant. That process is called isothermal system. That any reaction initial to final going means temperature dependent upon the constant. That means dt equal to 0. Next, isobaric process. In this process, initial to final state, the pressure will be constant. Pressure will be constant. That means dp equal to 0. Isochloric process, initial state to final state, and here volume only constant. That means dv equal to 0. Next, cyclic process. System will be returns. System will be returns to original state. That means du equal to 0, dh equal to 0, dp equal to 0, dv equal to 0, dt equal to 0. That is for cyclic system. That overview, adiabatic process means q equal to 0. In isothermic process means dt equal to 0. In isobaric process means dp equal to 0. Isochloric means dv equal to 0. In cyclic process means dv, dh, dp, dv, dt equal to 0. Next, state function. Thermodynamic system can be defined variables in pressure, volume, temperature, number of moles. Function is thermodynamic property of the system, the specific value of given state, and does not depend on the path manner which particularly state is reached. Example: pressure, volume, temperature, internal energy U, enthalpy, and free energy, etc.